All right, so we're looking at number 1 here. It says select all that work, basically. So here's our figure P, and first one is to rotate 180 degrees about point A. So I drew just a vertical line here, 180 degrees, it doesn't matter which direction you go. So there is 90 degrees, and then there is 180 degrees. But either way, you can tell that's P, and Q doesn't look anything like that. So you're right, A does not work. Rotate it 60 degrees. So these are equilateral triangles, which means each of those is going to be a 60-degree angle. So maybe kind of hard to tell on the video, but it looks like there's one triangle. And it says counterclockwise, so against the clock. That's going to go this way. So I'm going to make this line go up to where this one is, basically. Looks like it's about right there. And then reflect it over the line FA. So FA is going to be, there's F right there. It's going to be about right there. And if I reflect it over, it's going to kind of look like that. So it's looking like this, basically. And that's not at all what my shape looks like. You can kind of see through the patty paper maybe. So it's not B. So you had that one right. Letter C, translate it so that A is taken to J. So that means A gets pushed to J, which is what you drew here. So that's right. And then you're going to reflect it over line AB. So it's going to take it and flip it. So you slide it down, translate it over, and then you reflect it across here. And again, the paper is kind of at an angle, so it doesn't do it perfectly, but you can tell that it's pretty close. So yes, that one is right. Then reflect over line AB. So again, AB is right here, so we're going to flip it over here. So it should be kind of like that. And then, let me line it up. So it should look like that. And then it says translate it by the directed line segment AB. So you're going to move it as far as A to B, which is 1, 2 sides of the triangle, basically. So B is going to move down to where A is. And so we go 1, 2, and it puts it where it should go. So that one would work for sure. E, reflect over line AB. So kind of like that. And then rotate it 60 degrees counterclockwise. Okay, so I'm going to draw, here is, close as I can see, one part of a triangle. And so again, counterclockwise is going that way, backwards from the clock. So I'm going to take this line and move it kind of to where that one is. So about right there. And you can tell, hopefully, this is where the figure is. So that one does not work. So that's number 1. You said you understood 2. Number 6, there are 3 points in the plane. Select all the straight edge and compass constructions that would locate the point that is the same distance from the 3 points. Okay. Okay, so on this one, at first I thought it was a select all that apply, but what it means is you need what information to create one that is equidistant from the 3 points. So it's not a does A work or B work or C or D or E or F. It's which of these together will work. So this is a little bit different question than what you've seen before. So construct the bisector of the angle. I don't know if y'all even talked about that really yet, but if you have an angle and then you create this line, these two segments are the same. So if this was a 60-degree angle, then these two both become 30 degrees. Or if this was a 100-degree angle and you bisect it, then these would each be 50. But that doesn't tell you anything about the distance from a point out to this point. So it's not dealing with the bisector of angles, so not A or B. On this one, you have to deal with the perpendicular bisectors, which E and F do say perpendicular, but what it's talking about on E, construct a line, here's AB, and it just says that it's perpendicular, and that may not be the best drawn, but that's what it's saying, which doesn't tell you anything about a point being the same distance, because that would make this segment here obviously not the same as from A to that point. So it doesn't just need to be perpendicular. It needs to be perpendicular and bisector. And it does have to be both C and D. And if you create the two perpendicular bisectors that it has here, then where they intersect is going to be the same distance from all 3 points. So let me see if I can kind of draw one of them. So if you have AB here, this is a rough sketch. I'm not using a compass and a straight edge, but let's say that I were. There is your perpendicular bisector for that segment. And then let's do BC. So here is B to C. And we're going to say that these two are congruent and also perpendicular. And so that point there would be the same distance from here to here, as to here to here, as to here to here. And sometimes you're able to freehand it and it looks close. Sometimes it's not easy to freehand at all though. So hopefully that helps a little bit on that one. And you only need two, because the third line is going to have to go through that same point. So yes, you could construct it to verify that you did the information correctly on the first two perpendicular bisectors, but once you have two, then you're good. So that's why you only need those two. On number 7, this straight edge and compass constructions shows quadrilateral A, B, C, D. Is it a rhombus? All right, so they don't tell us if we have congruent circles, but this, hold on, let me get a highlighter. This circle here, every point from its center to its edge is a radius, and it's the same length. So from here to here is going to be the same distance as from here to here, because those are both the radius of circle B. Okay, then I don't know what to, I guess this is circle A here that I'm coloring in pink. If you look, yeah, it's circle A. Circle A. And then we've got circle C here. Circle C, this one and this one are both the radius of that circle. So if this one is, let's say these are both 5, then this one is also going to be 5, because it has to be the same as this radius. And then same thing on circle A here. This and this line segment are both the radius of circle A. So if this one's 5, that one has to be 5. So hopefully that helps a little bit. Colors sometimes can help you see that these are 3 circles, but they all have to have the same radius. Even though I didn't say it, this segment is shared between circle B and circle C. And then this segment is shared between circle A and circle B. So that's why it ends up being, yes, it is a rhombus, because all the sides are the same length.